Just take a second and look around you. Your desk, the floor, maybe the chair you're sitting on right now. Wood is absolutely everywhere. It's so common we barely even think about it. But the journey from a living tree to a stable, beautiful piece of furniture, well, that's a whole hidden scientific process. And if you get it wrong, it can be a total disaster. And I mean a real disaster. We've all seen this or heard the horror stories, right? A gorgeous hardwood floor that suddenly starts to warp and buckle. Or a custom cabinet door that just refuses to stay flat. It's so frustrating, it's expensive, and it just seems to happen out of nowhere. So, what's the deal? What is this invisible force that can literally twist a solid plank of oak? I'll tell you, it's not bad luck. It's a really powerful natural process that, if you don't understand it and control it, will win every single time. The secret culprit? It's water. Yep, just plain old water. Every single piece of wood you've ever touched is in this constant, delicate dance with the moisture in the air all around it. And the key to making perfect, stable wood products is all about managing the water inside the wood through a critical process called drying. Okay, so to really get why water is such a huge deal, we need to kind of zoom in and look inside the wood at a microscopic level. It really all comes down to the structure of its cells. A freshly cut log is just completely soaked with water. And this water exists in two different ways. First, you've got what's called free water, which literally just fills up the cell cavities. Think of it like water sloshing around inside a huge bundle of tiny straws. Then there's impregnation water, and this is the water that's actually been absorbed into the cell walls themselves. So the drying process kind of happens in two stages. First up is the easy part. That free water, the stuff in the cavities, just evaporates. At this point, the wood is losing a ton of weight, but its actual size, its physical dimensions, they don't change one bit. The real drama, that hasn't started yet. That first stage keeps going until all the free water is gone, and the wood's moisture content hits a really critical point. And that magic number is right around 30%. It's called the fiber saturation point, or PSF. And honestly, this is the single most important concept to get your head around. That 30% number, that's the tipping point. The second the moisture level drops below that fiber saturation point, the rules of the game just completely change. Now, the wood starts to lose that impregnation water, the stuff from deep inside its cell walls. And as it loses that water, the wood shrinks. If it gains it back, it swells. All the movement, all the warping, all the problems, it all happens below this 30% line. So the whole trick is to manage this shrinking process really, really carefully. But there's a huge challenge. The outside of a board is always exposed to more air, right? So it dries and it tries to shrink way faster than the wet core. This difference creates what's known as a humidity gradient. Now, just think about what this means. As those outer layers are trying to shrink, the still swollen, wet inside is fighting back, resisting. This creates enormous tension inside the wood. The surface gets squeezed while the core is getting pulled apart. If this difference in moisture gets too big, too fast, the wood literally rips itself apart, and that's how you get those big, deep cracks. So, how in the world do we manage this delicate process? Well, for thousands of years, there was really only one way. You just let nature do all the work. This is the traditional method of air drying. The whole thing really just depends on the local climate. You take your lumber, you stack it in these neat piles, and you use little stickers called stickers to separate each layer so air can flow all around it. It's a completely uncontrolled process, and it can only ever get the wood as dry as the air around it, which usually means a final moisture content of about 15%. Now, this classic method has some pretty clear pros and cons. Because it's so slow, it's actually a really gentle process that creates very little stress on the wood, so you get a high-quality result. And of course, you don't need any expensive machinery. But the downsides are huge. It can take years, the wood is totally vulnerable to fungus and bugs, and that final 15% moisture level, it's just not dry enough for wood that's going to live inside a climate-controlled house. So to solve the problems of speed and precision, we invented a technological solution: artificial drying, or as everyone calls it, kiln drying. A modern kiln is basically a giant, super sophisticated oven. Inside these chambers, operators have total control over everything: the temperature, the humidity, the airflow. It's all managed according to a super precise schedule that's custom made for the type of wood and how thick it is. The advantages here are massive. The process is incredibly fast. We're talking weeks instead of years. You can hit any exact moisture target you need, plus the heat kills off any fungus or insects. So what's the catch? Well, the machinery is extremely expensive, and if you use the wrong drying schedule, you can create those intense stresses we talked about and just ruin the entire batch of lumber. And this brings us to the most important point of all, the right drying method and the final moisture level you're shooting for. It all depends on one simple thing. Where is that piece of wood actually going to live? And you know, professionals don't guess about this stuff. They measure. For scientific, dead-on accuracy, they'll use a lab oven to find the exact moisture percentage by weight. But for everyday use in a workshop, they use these awesome handheld meters that give you an instant reading. And this chart right here, this is the secret recipe for stable wood. See, wood that's going to live indoors, like your furniture or your floors, it needs to be dried way down to a very low 6 to 8% moisture, so it can match the dry air in a heated home. But wood for outdoor use, like for a deck, is actually best left around 13 to 15%, so it's already balanced with the more humid outside air. And that brings us right back to where we started. The critical difference between a failed, buckled floor and a perfect, stable piece of furniture is this invisible science. It's all about making sure the wood's moisture content matches its final home. It's a whole world of physics and tension and equilibrium, just happening silently inside every single piece of wood that's around you. So now that you know the secret, I gotta ask, will you ever be able to look at a wooden table the same way again?